Question 7. What is direct current? Direct current is a current that moves in only one direction. The other type of current, of course, is alternating current, which repeatedly changes the direction that it flows in. Next question, radio waves. Suggest a property of radio waves that makes them suitable for use in communication. There's a few different things that you could have here. One is that they can penetrate through buildings. For example, if radio waves couldn't do that, then you'd always have to go outside to watch the TV or to listen to the radio. So that's a useful property. Another one is that they travel at the speed of light, which is 300 million meters per second. So that means that communications can be transferred from one point to another very quickly. And possibly the final idea is that the radio waves are not harmful to humans. As you're sitting there right now, you've probably got hundreds of radio waves passing through your body, and none of them are doing you any harm at all. Okay, so for microwaves and ultraviolet, we need to think of some uses and possible harmful effects on people. Uses of microwaves, possible uses that you could have are cooking. You can use microwave cookers to heat food, or communications. Your mobile phones use microwave signals. A possible harmful effect on humans for microwaves is that you can get internal heating of body tissues, so you wouldn't want to stick your hand inside the microwave cooker while it was on. A couple of possible uses that you can use UV for. They're used as fluorescent lamps. Those little lamps that are used to detect forged banknotes use ultraviolet fluorescent lamps. Second use is for hardening fillings at the dentist. If you've ever been to the dentist recently, okay, they've got a little machine that goes inside your mouth to harden off the fillings, and that uses ultraviolet as well. And for the possible harmful effects of ultraviolet, there's ultraviolet in sunlight, and that's the thing that can give you sunburn. And if you get exposed far too much, you can get skin cancer. And if you've ever tried looking directly at the sun, which I certainly wouldn't advise, okay, it can cause damage to your eyes or even blindness. Okay, so the first thing to note for question part C is that this diagram here is looking from the end of the loudspeaker. So if you can imagine, this is where the cone is on the loudspeaker around here, and this is the side view. This is the end view and this is the side view, and one's a projection onto the other. The first thing that we need to know is that there's a current in these wires here, and the second point is that it's a current in the coil, and also that it's an alternating current, so the current flows backwards and forwards through the coil. And because there's a current in a coil, that's going to make a magnetic field around the coil. And of course you can work out the direction that the magnetic field is in by using the right hand grip rule. If the current in the coil is alternating, then the field around the coil will also be alternating or changing, and that's another point in the mark scheme that you can make. But of course the field around the coil isn't the only field in the loudspeaker. Okay, there's a field due to another magnetic field due to the permanent magnet that is from north to south, so mark those fields on there. So that's another marking point in the mark scheme, that the field around the wire interacts with the magnetic field from the permanent magnet. The other way of thinking about this is if we use the Flemings left-hand rule. Okay, so for example here, if I say that the current's flowing clockwise around this wire here, okay, then at that point where I've marked the field, okay, then the current's going to be going in that direction. So if you get your left hand out and you align your middle finger with the current, and your first finger with which is the green line, and your first finger with the field, which is the blue line, then you should find that your thumb is pointing downwards into the page. So as I've said there, the Fleming's left-hand rule means that there's a force on the coil, which means that the cone, the paper cone that the loudspeaker is made out of, will move in and out, backwards and forwards, or vibrates. So then the final marking point is if with the force on the cone that's going to make the cone vibrate is going to make the air particles in front of the cone vibrate, which is the longitudinal wave that we know as sound. There's about 8 or 9 points that you can have there, and obviously you just need any 5 of those to score 5 out of 5 for that question.